Hey everyone, today we're diving into one of the most fascinating topics in astronomy, the mysterious origins of our moon. Have you ever looked up at the night sky and wondered, how did the moon get there? Well, buckle up because the story is more thrilling than you might think. Scientists believe the moon formed about 4.5 billion years ago. But how exactly did it come to be? The most widely accepted theory is something called the giant impact hypothesis. It sounds like the title of a sci-fi movie, but it's actually grounded in some solid science. Imagine this. Our young Earth was minding its own business, still forming and cooling down, when out of nowhere a Mars-sized protoplanet, which scientists call Theia, came crashing into it. This colossal collision was nothing short of cataclysmic. It blasted a massive amount of debris into Earth's orbit. Now here's where things get even more interesting. This debris, composed of molten rock and metal, gradually coalesced and started to form our moon. It's like making a snowball, but on a cosmic scale. Over time, this material cooled and solidified, creating the moon we see today. But why do scientists support this theory? Well, we've got some compelling evidence. First, the moon's composition is strikingly similar to Earth's mantle. This suggests that the material that formed the moon came from our own planet. Plus, moon rocks brought back by the Apollo missions show isotopic similarities with Earth rocks, backing up the idea of a shared origin. Still, the giant impact hypothesis isn't the only theory out there. Some scientists propose the moon could have formed through a process called co-accretion, where Earth and the moon formed together from the same disk of dust and gas. Others think a series of smaller impacts might have gradually built up the moon over time. However, these theories don't quite match the evidence as well as the giant impact hypothesis. And if you think the story ends there, think again. The moon plays a crucial role in our planet's stability. Its gravitational pull affects our tides, stabilizes Earth's axial tilt, and even influences the length of our days. Without the moon, life on Earth might look very different. So next time you gaze up at that beautiful, glowing orb in the sky, remember, it's not just a celestial neighbor, it's a testament to the dramatic events that shaped our solar system. The moon's mysterious origins remind us of the incredible forces at play in the universe and our own planet's dynamic history. Thanks for joining me on this cosmic journey. If you enjoyed this video, give it a thumbs up, and don't forget to subscribe for more mind-blowing science content. Until next time, keep looking up.